Hi all, welcome back to Chemical Engineering Statistics. As an opening for the Inferential Statistic module, this time we will discuss about the concept of inferential statistics. Let's get started. Now, please try to imagine the situation in the beverage factory which is shown in the left figure. With the company's motto that prioritizes product quality, thousands of bottles produced every day must meet various standards, such as filling volume per bottle, consistency of taste between bottles, physical conditions of bottles, and others. Of course, it is impossible for the factory to carry out a census to maintain the quality of their products. Moreover, if the data collection process turns out to have the potential to damage the product, it becomes even more economically unprofitable. Another example is monitoring of water quality as performed by the environmental technicians on the right. Of course, it is not possible to carry out a census of a body of water, which is clearly a conceptual population. These two examples illustrate that we cannot know the true value of a population parameters. Because there is no other choices but to do sampling, we must be able to estimate the population parameters based on the results of the sample measurements. The set of mathematical procedures for processing the sample so that we can draw conclusions about the populations from which the sample originates is called the inferential statistics. As previously discussed, the justification for this inferential statistics is the central limit theorem, which states that there is a mathematical relationship between the characteristic quantity of the sample and the population parameter. In general, statistical inferential statistic includes two types of methods. First, searching for approximations or estimating population parameters. And second, hypothesis testing to check the acceptability of claims about the population parameters. Here I present two examples of inferential statistics cases. On the left, we want to express the average diameter of the steel grinding ball. Because of course it is very impractical to measure all available balls, we just take a few items as samples. Then we state the average diameter of the spherical populations as the average or as the mean of the samples we took earlier, corrected by the size of the sample error. On the right, statistical inferential statistics is carried out to check whether the energy content in this portion of cereal is true as the manufacturer claims, which is 100 kilocalorie. In general, there are two approaches we can take in expressing the parameters of population, whose true value is impossible to be known. The first way is to approach the point or by doing point estimate. For example, you are asked to state the average weight of onde-onde in this picture. You take a few items as a sample, then measure the weight of each item, calculate the average value, then you report what it is. Now, that means you are approaching the true value of the onde-onde population mean with just one sample characteristic. This is what we call as point estimate. On this page, you can see some examples of point estimates for the population parameters they represent. I am sure you have calculated at least some of them, just maybe haven't realized that what you're calculating is a point estimate. So that is the video lecture this time. See you in the next video.